So for this project, what we have turned our embedded board into a binary clock. I've had it running for a few minutes now, as you'll be able to tell in just a few seconds here. But we also have it hooked up to our oscilloscope here, so we can actually see that the on-off cycle every counting second is actually, in fact, 1 second. So as we can see right there, our period is 2.01 seconds. That would mean that every point from the rising edge to the next rising edge is 2 seconds. So every half of that, where our light is on here, is 1 second. Therefore, we're on for 1 second, off for 1 second, on for 1 second. That's how we count in binary, but that is just proof that our timing for this clock is correct. So what's happening here is there's 1, 2, 3, 4, 5, 6, 7, 8, 9. Then we pop over, that's 10. So what I've decided to do here, because it's horizontal, is have a ones column and a tens column. So now this is saying we're at 6 seconds. So this here, this port D, is our seconds. Port C is going to be our minutes. So as of right now, this has been running for 1, 2, 4, just about 5 minutes. Port B, we don't have anything right now, but that's hours. And the way I have the binary clock set up is 24 hours. So when this is, we'll say filled, when this has reached 23 hours, 59 minutes, and 59 seconds, then we will roll over and restart, and we will go back to 1. Now, throughout the day, this could tell time, but only if you were to start it at midnight. But we haven't done that. It's 11:30 p.m. now. We were pretty close. But I'm going to now restart it so we can see how it begins the count, and then we'll see this little bit of flickering here on the oscilloscope as it loses itself and tries to recapture the wave. So first we have to reset our board. We'll reconnect. You can see our timing is flatlined. We're not doing anything right now. There we go. All right, code should be launching back into the board. And there we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And very quickly, our timing evened right back out to just about 2 seconds. And we can see on a large enough timeline, if we zoom out in our oscilloscope, that it will just stay like this effectively forever until we decide to turn this off. But this particular square wave here that we have will never change. That's just the way the timing in our code has worked. So yeah, that is how the binary clock works for this project. The details of the code and everything will be in the PDF to follow.